Recording in progress.
I have no graphic. Is one okay? You make your own grid, and be pretty accurate about it. Want to check in with the neighbor, make sure it's on okay with them? Feels good, doesn't it? I'll take that as a yes, Mr. Lieberman. This is amazing. I'm happy to do this first in the morning. A quick mic check. Check 1, 2. Check 1, 2. We got Baron checking on Zoom. Do you feel his presence? On count of 3, everyone say, good morning, Baron. 1, 2, 3. Good morning, Baron.
Hola,
I hope
I'm here.
he's there. Oh, there he is.
No, I'm
Can you
here.
hear us
Don't worry.
okay?
Yeah, I'm all good.
Okay.
I have my graph sketched out.
Oh, look at Baron has his graph sketched out. Do you?
Hey, just out of curiosity though, any chance I can be taken out of the popsicle stick cup for today?
Oh no, I'll leave you in. Don't worry. I wouldn't take you out of the popsicle stick cup.
Awesome, lovely.
You're welcome. Okay, let's talk about these. In gestures, Baron, you could do this on your own if you like. I can't see you, so, but I'm just gonna look for gestures for. Go ahead, hold up your pocket parabola, and show me what this 2 is gonna do to your pocket parabola. It stretches it, doesn't it? So now the parabola is narrower than it would be, and the 1, what does that do with it? Moves it up 1, and which one comes first? The stretch or the shift? The stretch comes first, and then the shift. So when we go to it, I'm gonna go directly to graphing at the vertex we know is at 0, 1. Are we okay from that? And it's already stretched, excuse me. So the other points I'm gonna use the 1A, 3A, 5A pattern. Did you use that for this? In this case, A is 2. So it's, we're looking at 2, 6, and 10. So from this point, I'm gonna go up 2. At this point and this point. Oh, is it frozen? Oh, yeah, it is frozen. Sorry about that. And then from there, I go up another 6 and 3. So I'll go up 1, 2, 3, 4, 5, 6. And bam. So this is really narrow, and I'm definitely not going to do the other ones. And just so I could, for ease of reading, 1, 2, 3, 4. I'll put a 5 right there. 2, 3, 4. Yeah, I guess that's all I need. Any questions? Just a full house. In this case, we know that the vertex is x. 1, 2. And if I'm going to use the 1, A, 3, A5 at A pattern, this now becomes 1/3, 3/3, 5/3, or 1/3, 1 5/3. I know this would be much easier to graph than the graph paper, but let's see what I could do. So I'm going to go up, not a full 1, but 1/3 about there and there. Does that make sense? Those 2 points? Maybe I can zoom in a little bit here. From there, I'm going to go up, make that a little bit more even. 1, 2, 3. Yes, that's even. So here-ish. Try to go up 1. And from there, I'm going to go up 5/3, which is the same thing as 1 2/3, which brings me nicely to this point up here. Getting our parabola like this. Now, quite honestly, what I care about most is that you hit this point right there. If you got that vertex, I'm quite happy. If you had forgotten about some of the other points, and I don't know if we focused on that 1A, 3A, 5A. Oh, did I mention it? The 1A, 3A, 5A? Okay. I think it's a really nice way to graph these. And we have never graphed anything like this. Do you have any idea what this is? Well, there's only one quadratic, so it is a parabola, but because it's the y's that are squared, this is a parabola that is opening. Yeah, to the right. Sorry, to the left.
Isn't
So the
it not a
vertex for
function
this.
then?
Say that again.
Isn't it not a function then?
Correct. It's not a function of x, but it's a function of y. So it's that's a horizontal line test. And we're going to be using some of these in today's lecture. So I just want to give you a brief introduction. Now, if it's just x equals y squared, then we have a vertex here. Then our 1, 3, 5 pattern would just be going to the left. So here I would have this 1 and 1. I have the 3 right here. 1, 2, 3. Something like this. Does that make sense? Since x and y's are reversed, it's just going to be going in the other direction instead of up. But let's check just to make sure. Like this point right here is 4, -2. Does that actually fit on this function? Yeah, it does. So does the point 4, 2. They both fit there, don't they? Definitely not a function of x. It fails that vertical line test, but it is a function of y, which you'll talk more about next year. But I just at least want to give you a little window into it. So if I want to do x equals 3y squared, what do you think is going to happen to that parabola? Same thing I would do vertically, except it's going to stretch in a horizontal way. So that 1A, 3A, 5A becomes 3, 9, 15. I don't think we're going to be able to plot many of these points. We know that the vertex is here at the origin. To get 2 more points, I'm going to go over 1, 2, 3, 1 and down 1. Does that make sense? In America, we have this nonverbal gesture that we do with our heads. If it's up and down, it means yes. If it's side to side, it means no. If it's nothing, that means I have no idea what you're thinking, but are we okay with the 2 points, other points that I've done? Those 3 over? Are we knew that it's opening to excuse me, it's opening to the right, isn't it? I would go 3, and then if I want some more points, I'm gonna have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, up here down here. I'm definitely not gonna go over another 15. That'd be crazy. Although I've done some crazy things. I'm not looking for trouble today. Yeah. Any questions? Okay, perhaps your question might be, can we get started on the packet, please, Mr. Lieberman? The answer to that question is absolutely. Look at this right off the bat. We're doing a state systems of nonlinear equations in 2 variables. Let's see if we could graph this already. Here we write the second one as x equals -1/4 y squared. Check with your neighbor, make sure everything's going okay with their graph. Okay, that parabola, would you show me what it looks like? Your pocket parabola, go ahead, hold it up. Yeah, this is actually opening to the left. I think I reversed my left and right earlier. I'm sorry. I was originally talking about the sideways parabolas. This was actually opening to the left. The vertex is at the origin, and if I want some points, I could get some by just multiplying my 135 by that -1/4. So I have -1/4, -3/4. Is that right? -5/4. Do we see any sort of intersection here? So does that look about right? -1/4, -3/4. Oh, look at that. -5/4. Did I do that right? It's just 1 1/4. Oh. Is it gonna hit that line again? I don't think so. It looks like it's pulling away from it. So something like this. What's that relationship called that we're looking at? Yeah, tangent, isn't it? Yeah, that would be called a tangent line. You're going to study those in extreme detail in calculus. So there we go. We've solved it by graphing. It looks like the solution is -1, -2. And whenever you solve by graphing, make sure that you do what? Do you know? If you solve something by graphing, you must check. What if your graph is wrong? At least check in your head. Let's see, is -2 equal to -1 minus 1? Cool. Is y squared equal to -4 times x? Let's see, y squared, that gives 4 equals -4 times yeah, it works. Okay, so it's definitely a point of intersection, but perhaps you agree that that kind of sucked. That, right, graphing in such detail. It was okay because we had the graph, but imagine that we were doing like the warm-up, like you have your own x and y axis. That's why we prefer solving algebraically instead of graphing in general. So I can give you a moment to go ahead and do that. I think you could do this already. I believe in you. Discuss the first step with your partner, with neighbors. And Brendan, I'm gonna have you come back here, sit next to Emma for today. You have a direction? I'll be calling on someone just like less than a minute to see what you've done. You're solving this algebraically, so same problem. Oh, had you moved on to the next one? Now we're solving this algebraic. You get it? Okay, I'd like to hear how far you've come. Baron, I'm sorry to tell you, it's not you.
No worries.
He's relieved. And Priscilla, can you help us out with this, please?
Yeah, I can. So I used the
Right.
substitution method.
Okay,
So we already have the y equals x minus 1.
okay.
So then I got x minus 1 squared equals -4x. And then
X minus 1 squared equals -4x. Okay,
I did x squared minus 2x plus 1 equals -4x. And then I have x squared plus 2x plus 1 equals 0. And then that factored into x plus 1 squared equals 0. And then I got x equals -1. And then I plugged that into the original y equals x minus 1 equation, and I got y equals -2.
are we good with that? Okay. Yeah, when you plug that in, you get that nice -2. That's great. Thank you so much. Any questions? And of course, this particular system of equations just had one solution, but can you imagine it having more than one solution? How many are even possible? Could it have two solutions? Could it have three solutions? A line and a parabola, could they intersect three different times? I'm not sure about that. Could it have infinitely many? Infinitely many? I don't think a line and a parabola could do that. You definitely have 0, 2. So I think 0, 1, and 2 are that. Okay, I'm going to recommend that you do not graph these. Go ahead and solve by substitution. Make sure to check in with your neighbor when you are done or stuck with each problem. I do want to call on 2 people to help us through.
I think, yeah.
Already got something for A. A couple people. Keep on going. I'm expecting to work on A and B. If neither you nor your partner know what's going on, maybe you can check with people in front of you, behind you, the other side of you. Ready? I give about 15 seconds. Destiny has already chosen 2 people. Okay, we ready? Let's at least do the first one. James, can you help us out with this one, please?
Yeah, so to start, I subtracted subtracted a 3x, which gave me negative y equals negative 3x plus 9, divided it by a negative, everything a negative. That gave me y equals 3x minus 9. And I substituted that into the first equation. And ended up with x squared minus 6x plus 8 equals 0.
X squared, say that again, x squared
X squared minus 6 plus 8 equals 0.
minus 6x plus 8
Yeah, equals 0.
equals 0. Okay.
Or, hold on. I think I got minus 8 actually.
I didn't get minus 8. Let's see.
Yeah,
I think plus is good.
plus is good.
Yeah. Is that right? Is it plus 8? Okay, yeah. On the right side, it's minus 8, but it moves everything.
Then from there, I got x squared. Well, I got x minus 4 times x minus 2 equals 0. And that gave me x equals 4 and 2.
Okay.
And then I plugged that back in, and that gave me my points were 2, negative 3, and 4, 3.
2, negative 3, and 4, 3, you said?
Yeah.
Do we agree? Any questions, comments? Nicely done, James. Thank you. B. You may not have finished, but I want to hear what you've done so far. Ryan, can you help us with this one, please?
Yeah, so I found the value of x first, and that's just x equals 3 plus y.
Okay.
I plugged it into the second equation, and it turns out to be 1 plus y squared
Square. Okay.
plus y plus 3 squared equals 4. Then that simplifies to y squared plus 2y plus 1 plus y squared plus 6y plus 9 equals 4.
Okay.
By like terms, you get 2y squared plus 8y plus 10 equals 4.
Plus 10 equals 4. Okay.
And then you subtract the 4, so it's 2y squared plus 8y plus 6. And then you can divide by 2. So it's y squared plus 4y plus 3.
Thank you for dividing by 2. It makes it so much simpler.
And then not dividing by 2, but the two solutions, two equations, y plus 3 and y plus 1.
Okay. So you factored it. Good.
Y could either be negative 3 or negative 1. And I tested, I don't think negative 3 works, but I think negative 1 might be the answer.
Well, let's check. What happens if you plug in negative 3? Oh, it's y equals negative 3, isn't it? Y equals negative. If y equals negative 3, then x would be equal to 0. Do we see that? Just from right here. All right, go ahead and plug it into that one. And then the other one, if y equals negative 1, then x equals 2. So this definitely works on the line. Does it work? What's the shape of the second one? Can you show me the shape of the second equation in B? Do you recognize what that is? It's not a parabola. Anyone? That is a circle. Center at 2, negative 3.
Wait, you said it's a
And you'll
circle?
be discussing that in more detail next year, but let's just see if it works. 2, negative 1. If I plug it in, I have 0 plus 2 squared. Cool, that one works. And if I plug in the other one, 0, comma 3, we get negative 2 squared, it's 4. 4 plus 0 equals 4. Cool, they both work. Ryan, that was fantastic. Thank you for your help. Any questions? Perhaps your question is, can we try some more? I think you're okay. I think you can do this. If you can do the last ones, I think you're okay. So let's move on to. So was there a difference here? Oh, it wants us to solve using elimination. Okay, that is a significant difference. I don't know why they want you to use elimination for A, but for B, do you see that would be pretty straightforward? Let's at least start this one for B. Y equals x squared plus 3 And I need that x squared under here, so maybe x squared plus y squared equals 9. I'll set it up like that. I'm just trying to set myself up so that when I either add or subtract, or get rid of something, so I will of course subtract here. I'm left with y minus 9 equals 3 minus y squared. You see what I did there? I just kind of lined it up so that like terms canceled. And you can see how to proceed from there. I'm not going to baby you through it. And yeah, let's do both of these. That has some interesting twists. A and B, please. Anyone finish A already? Anyone finish B? You show me how many solutions you got for A, just out of curiosity. Cool. Okay, I'd like to hear. Sasha, can you help us with A, please?
I wasn't sure about this one, but I did,
You want to go right to B?
oh, sure, I could do either.
Do you have a preference? And I just, you said you weren't sure about this one, so give me the option.
I can
Okay.
try. Okay, so I substituted, y cubed for 9, or for x, so it's y cubed equals 9y.
Nice. Okay,
And can you divide by y on both sides?
that is a fantastic question. Can we divide by Y? It's an equation, so really you can divide by any number, but I urge you to never divide by a variable. So thank you for considering. What's our other option if we're not going to divide by it? That kind of throws everything out of order, doesn't it?
Subtract 9y from both sides.
Yeah, let's subtract 9y. Good. Switching it up quick. Nice.
Why can't you divide by
And there,
y?
instead of dividing by Y, see what to do?
Yeah, okay, so, then you do y minus three times, or y, yeah, y minus three.
Well, both terms have a y, so we're gonna take that y and
Oh,
factor it out. Right, so we're gonna, that leaves us with y times,
oh, y squared minus,
yeah. And now I think it's gonna be a little bit,
oh,
you see everyone's like erasing their work now. I don't blame you one bit, that was a curveball for sure. Sasha, what can I do with that y squared minus nine?
you can expand it, so y in parentheses, y, minus three. And or y plus three.
Nice, yeah, we could factor it. Now we see that there are actually how many solutions?
Two,
What are the solutions?
positive and negative.
Minus three, is that it? Also
And zero.
zero, and that's the one that I imagine many of you lost when you divided through y, when you divided by y. And perhaps you can see, well, let me finish. Sasha, are you okay continuing?
Oh, for x.
Yeah, we need to
Oh, okay.
x's. Do you want to use the first equation or the second?
A second.
It's a good idea.
So x equals positive or negative 27
Okay.
or zero.
We're good? Sasha, that's fantastic. And I really like how you switched it up. You were able to switch it up on the fly like that. Thank you. And in retrospect, you see looking at it that it's actually kind of obvious that 0, 0 is the solution to both of these without doing any work. That's called a trivial solution. And very often if you're hasty with your math, that one kind of goes away. So be careful, never divide by a variable or variable expression. But any number is fine. Should we sketch it out? Nah, let's trust it. Let's trust the work. Okay, I want to at least get it started on this one. B. Brandon.
The first, what I did was since x was y equal to -5, I subtracted y from both sides, so I got x is equal to -1 minus 1. And then I plugged that value for the x in the first equation. I got negative y minus 5 times y is equal to 6. So, and then when you multiply that out, you get negative y squared minus 5y plus 6 is equal to 0. And then if you divide both sides by -1, you get y squared plus 5y plus 6 is equal to 0. So you can factor that out into y plus 3 times y plus 2. And then you'll get y is equal to -3 and -2. And then if you plug that back in, you will get x values of -2 and -3. So then your coordinates are -2, -3, and -3, -2.
Sorry. Couldn't write that fast. What were the x coordinates of these?
-2 and -2, -3, and -3, -2.
Oh, interesting. Are we good? That was great. Thank you. Did they both work? When you solve it algebraically and you're pretty sure that your steps are correct, you don't have to check like you do with graphing, but it's a good idea to look back and say, do they work? We can see it's actually pretty easy to check both of these, isn't it? The product of both is 6. The sum of both is -5. Done. Okay, we have a little grand finale. So I'm going to give you until 8:45 to go over any questions that you may have had, or just zone out if you like. We'll continue momentarily. Okay, 8:45. Let's finish this off. Give you some time to work on your stuff for this weekend. And yeah, applications of a nonlinear system. So let's say you have 36 yards of fencing to build an enclosure in the figure. I think they may be missing a figure. Some of this fencing is to be used to build an internal divider. If you'd like to enclose 54 square yards, what are the dimensions of the enclosed? There's no figure, so what we're going to do is make one. What should this figure look like? A rectangle. Usually enclosures are rectangular. It could be circular. In fact, they haven't actually given us one. Because it's kind of open, but let's assume it's rectangular. And there's an internal divider, which I'm going to say is right here. Arbitrarily put right there. So what are the dimensions of the enclosed? So in other words, what is X and what is Y? Let's see if you could already make the equations. Read it, discuss with your neighbor. Some equations you could write here.
What are the
Yes, Sienna,
Is that for the total answer or just?
total. It's everything. Okay, do you have a couple equations? Because we have two unknowns, we need two equations. So what's one of, well, what, any ideas? Yes, yeah.
I have.
Search.
Do you have two equations?
Yeah, I switched that.
Okay,
So I guess.
you switched X and Y?
Yeah, I can,
Okay,
I have 2x plus 3y equals 36. And X, Y.
Does this make sense? Do you see very clearly the 3y here? Or if you relabeled your variables the other way, 3x, I imagine, should be fine too, as long as you're consistent. And then from here, you know how to solve something like this? I'll give you a moment to solve. Do you get anything? Okay, you ready? Ava, could you help us out with this, please?
Sure, I didn't come to it, but so I solved for X and I did.
One for the first
Oh,
equation?
for the first equation.
Okay,
X is 36 minus 3y. And then X is equal to 18 minus 3. We have y.
okay.
And then I plugged it into the second equation.
Oh my. Okay,
Minus halves y squared equals 54.
Okay.
And then I multiplied by -2 to take out the fraction.
nice, I really like
I switched it to make 3y squared minus 36 minus 108 equals 0.
minus 108
Oh, plus 100.
or plus 108. 108 equals 0, okay.
And then I factored out 3. So it's 3 and then y squared minus 12 is 26.
What if I just divide by 3?
And then I didn't finish out.
Okay, well, what is the next step?
Oh, and it's factor it. So it's y minus 6 squared. And then y is equal to 6.
6, so x is equal to should we plug it into the first equation, the second one? It's equal to 9. Are we good with this? Any questions? Ava, nicely done. What would be an appropriate answer for this question? If this is an ordered pair? Yes, Sienna. Right out the dimensions. And for something like dimensions, I don't really need a sentence answer. You could say, I would want units, so 9 yards by 6 yards would be sufficient. You don't have to say the dimensions are You don't have to say the length is this, the width is that, just the dimensions, because it doesn't matter which is which. Any questions? Yeah, thank you again. Oh, of course, this is a typo. That last one is a typo, right? What are the dimensions of the enclosed? Should be dimensions of the enclosure, I imagine. I felt so awkward saying that. Closed what? Enclosed, the enclosure. And lastly, find the length and width of a rectangle whose perimeter is 20 feet, fencing and an area of 21 square feet. I think you could do that. I'll let you have some time for your homework. What do you think? Okay. Great job, folks. Baron, you made it through. Well done.
Bless, thank you.
Sorry I didn't call on you today.
No, no worries.
Oh, you're very, very kind.
No worries.
In the log.
Yeah,
Take care.
it's kind of rough. All my work was on Marriott note cards.
Okay. I love it. Thank you. Take care.